Good morning. This is Dr. Mayer. This is our discussion related to Chapter 9, which is audit sampling. The intent of this class is not to give a statistical analysis of what audit sampling is, but to provide an overview for auditors from a very practical perspective as auditors assess the sampling methods that they'll be using as they're conducting the audit. Before we start talking about the mechanics of audit sampling, I want to take us back to the audit report where we explicitly state that we are examining on a test basis. So within the audit report, we are telling the reviewer of the financial statements that our opinion is based upon a sample and not the complete population. We have explained the reason for sampling. We need to complete the audit within budget and within a reasonable period of time. When sampling is done correctly, we are able to meet these objectives. Throughout this course, we talk about risk from a number of perspectives. Let's now talk about sampling risk. So you notice that we have the potential for the risk of incorrect acceptance and the risk of incorrect rejection. So basically what this means is that if we take a sample and we see that within the sample a material misstatement, but in fact there is no material misstatement, this is the risk of incorrect rejection. On the flip side, if we see in the sample that there is no material misstatement, when in fact the financial statement or the component that we're looking at is materially misstated, we now have what we call a risk of incorrect acceptance. Much of our discussion related to sampling is in determining the sample size. You notice that there are three elements that we need to consider. The first is confidence level, the desired level of assurance related to the results, the acceptable defect rate, which we call the tolerable error, and the historic defective rate, or the expected error. The first element related to determining the sample size is our confidence level. The confidence level is the complement of sampling risk. We identified sampling risk earlier, and basically what we are attempting to manage here is the amount of risk that we are willing to accept. So if we're willing to accept a 5% sampling risk, this means that we have a confidence level of 95%. All other variables being equal, the greater the confidence level, the greater the sample size. Obviously, if we expect a 100% confidence level, we're going to have to test the entire population. Auditors generally gravitate towards that 95% confidence level as they are completing testing. Let's now address the last two elements related to sample size, and this is the tolerable and expected error rate. Given that the auditor is looking for reasonable assurances, we are able to tolerate a certain amount of errors within the financial statement. We need to compare this to expected error. So the problem becomes, or the element that we consider in terms of sample size, relates to how close the expected error rate is to the tolerable error rate. If we can tolerate an error rate of 7%, but the expected error rate is 2%, then we're not going to have a very large sample size. But the closer the expected error rate gets to the tolerable error rate, the greater the sample size. We're going to go to the IDEA software next and show how these three variables will actually impact the ultimate sample size that we will end up with. We are now in the IDEA software where we are looking at identifying a sample size. So when you look at this, you notice that we have a population of 10,000 elements. Let's say there's 10,000 accounts receivable. We have an expected error rate of 5%. We have a tolerable error rate of 7%, and we have the confidence level set at 95%. Based upon these variables, we see a sample size of 457. The conclusion is if no more than 23 deviations are observed in a sample of 457, you can be at least 95% confident that the population deviation is not more than 7%. Now, I want to just do a couple of things. Let's say instead of having 10,000 items, we have 100,000 items. We compute this, and what you notice here is not much actually changes. Sample size went to 477. So you notice that the population size doesn't have a significant impact on the sample size. So let's now go back to the 10,000 units and recompute this so that we get our sample size 457. But instead of saying that we want 95%, we now want 90%. When we compute this, you notice how the sample size drops significantly. It drops down to 300. So the conclusion here is the greater the confidence level that we want, the greater the sample size. So let's put this back to 95. And I want to now look at what takes place related to the expected and the tolerable error rate. So again, we're starting off with a population of 10,000. We have an expected deviation rate of 5%. We have a tolerable deviation rate of 7% and a confidence level of 95%. At this point, we have a sample size of 457. Let's say there is a significant difference between the expected and the tolerable error rate. And by the way, in the slide, you notice that the difference that we talk about is what we call precision. But in this case, we're saying we're only expecting 2%. We can tolerate 7%. Let's see what happens to the sample size. Well, here in the sample size, you notice that the sample goes down to 88. So in this case, what we're saying, if no more than 2 deviations are observed in a sample of 88, we can remain confident that 95% confident that the population deviation rate is not more than 7%. However, let's say we change this to 6%. So in this case, the expected deviation rate is getting closer to the tolerable deviation rate. In this case, what we're looking at here is we're looking at a sample size of 1,533. So again, the conclusion is if no more than 92 deviations are observed in a sample size of 1,533, you can be at least 95% confidence that the population deviation rate is not more than 7%. Through this analysis, we can see how these 3 variables, and these really are the 3 variables or the 3 elements that we consider as we are looking at the sample size. We can see how that by manipulating these, that the sample population will increase or decrease based upon these expectations. Let's go back to the slides and go through a number of definitions that I think are critical to our understanding of sampling. The first thing that we need to understand is that there are what we call non-statistical sampling and statistical sampling. The key elements between these two is that in non-statistical sampling, we are attempting to zero in on a specific element within the overall population. Generally speaking, if we're looking as an example at issues related to fraud, is we're not looking at the entire population, but we're looking at a specific element of the population, maybe a day of the week or a specific individual that completes transactions, which is exactly what we need to be doing. The problem is, or the issue that we need to be considering is the fact that when we do this type of testing, the results cannot be extrapolated to the entire population. When we are doing statistical sampling, what we're doing is we are attempting to identify a sample that replicates the entire population, such that when we look at the sample and we draw conclusions on the sample population, that because we are using a statistical sample, that we can extrapolate the results from the sample to the entire population. We use statistical sampling generally in the test of controls and our substantive testing. where we're attempting to identify a sample that is reflective of the entire population. The advantage of this is that we're able to design efficient samples. We're able to measure the sufficiency of the evidence and objectively evaluate sample results. Again, with statistical sampling, the goal is to take the sample and extrapolate this to the entire population. So the conclusions that we make in the sample reflect the entire population. We will conclude this discussion to talk specifically about several types of auditing plans. You notice the first item here is attribute sampling. We generally use attribute sampling as part of our test of controls. You notice the key word is attribute. So in this case, what we're looking for is we're looking for a specific attribute. So as an example, if the internal control states that any check over $10,000 requires 2 signatures, well, that's an attribute that we're looking for. So we would take a sample of checks over $10,000 and look specifically for the attribute associated with that second signature. We talked about discovery sample when we talked about fraud testing. In this case, what we're using is we're using a non-statistical sample and identify a sample based upon specific criteria. For example, if we're looking at transactions that occurred over the weekend, specifically because over the weekend transactions may be taking place without proper supervision, we would limit our search for transactions that only occurred on Saturday and Sunday. The last element that we want to talk about is monetary unit sampling. This is a strategy that we would use where we want to make sure that high-value transactions are given priority over low-value transactions. So as an example, there may be transactions that are $1 million and other transactions that are $10. If we pick our sample based upon the total population, each of those items have the same probability of being picked. However, with monetary unit sampling, the population is not the number of units, but the actual dollar value. So what happens here is the probability that an item will be picked will be dependent upon the dollar value of the transaction. This is an example of what we call a probability proportion to size. And again, the population is not the number of units, but it is the total dollar value that relates to the total number of units. This gives us a brief idea of some very basic definitions related to sampling. I appreciate your time and I look forward to our next discussion.